So girls, in our first week of this topic, we had a look at how metals react with oxygen. When they react with oxygen, they produce the metal oxide. Last week then we had a look at how metals react with water. And when metals react with water, they produce the metal hydroxide and hydrogen gas. This week, we're having a look at how metals react with acids. And metals react with acids to produce a salt and also hydrogen gas. So we'll test for that gas again this week. In your notes, you look at the experiment of copper, magnesium and zinc with hydrochloric acid. And I have those chemicals with me today, and we're going to have a look at those reactions. So we'll do copper, then we'll do magnesium, then we'll do the zinc. We'll do them in alphabetical order. So what I've got here is my hydrochloric acid, and I'm just going to pour it into the beaker just so that it's a bit easier to then pour into my boiling tube. I'm doing it in a slightly different way, I suppose, than your notes. I'm using boiling tubes instead of test tubes, just for the sake of the video so that you can see those a bit more clearly. Test tubes are a bit smaller. So I will just pour my acid into the boiling tubes rather than using a dropper, but the same principle is the same. So what I'm going to do with my copper, first of all, is I'm just going to take a small strip and I'm going to place it in the boiling tubes. Okay, so I'm going to put that in the first boiling tube. What I'm then going to do is I'm going to just pour a small amount of my acid, just enough to cover it, into the boiling tube. Okay, so let's have a look. Again, it might be hard for you to see from the video, but I'll do a close-up in just a minute. But have a look at the copper. Is it reacting? No, there's nothing that we can see, no clear observations. And as I've just told you, when a metal reacts with an acid, we produce a salt and we produce hydrogen gas. So if that reaction was happening, we would see bubbles right now because the hydrogen gas would be given off. So we can see that copper does not react with acid. And last week, we would have seen that it was the least reactive out of our metals. And you can see that it doesn't react with water. We saw that last week. But we can see from today that it doesn't even react with acid either. Copper is very, very unreactive. Okay, next we're going to react magnesium. So I'm going to get just a strip of magnesium and I'm going to place it in my boiling tube. And again, I'm going to pour some acid over it, roughly the same amount as with my copper. And already you can see a reaction is happening and you might be able to hear it too. So let me hold that up for you. You can see that there is fizzing happening in this boiling tube. Sometimes that's called effervescence. It's just a fancy name for fizzing. You can see that we're having bubbles of colourless gas being produced. Okay. And if I put my hand around the outside of the boiling tube, I know you can't feel that from just watching a video, but the boiling tube is getting very warm. So this reaction releases heat. You can write that down as one of your observations, that the reaction releases heat. Okay, we'll leave that reacting for just a minute. What we should see is that eventually, once all the magnesium has reacted, it will have disappeared and we'll have a look at what we are left with. So I'll give that just a quick shake to get that all mixing. Okay, then our next one is zinc. So we'll have a look at that while the magnesium is still reacting. And you can see here I've got zinc granules. So they're just essentially small lumps of zinc. So I'll pour a few of those into our boiling tube. And just as I've done that, our magnesium has pretty much finished reacting. There's a bit on the edge that I'll try and get in. So just my last bit is finished reacting. You can see that last bit of fizzing, that small bit of magnesium has just floated to the top now and is finishing its reaction. And what you can see we are left with is a colourless solution. So it's not turned blue or green or anything. The solution is colourless. That's the solution of the metal salt that we've produced. And the fact that we have reacted magnesium with hydrochloric acid means that we've produced a salt called magnesium chloride. And because that's soluble in water, then it forms a solution. So it's not a solid that's formed, it's a solution. And you can see that it's colourless. You can see the tiny bit of magnesium just reacting at the top there. But let's have a go at reacting our zinc and see how its reaction compares. So again, we'll try and put roughly the same amount. Okay. And it might be hard to tell from the video, but you can see a few bubbles of gas being produced on our zinc. Just really on the surface at the minute, and they're starting slowly but surely to rise up to the top. That might be hard for you to see from the video. I'll give them a little shake and you can see a few more of those bubbles. So what we can see is that zinc is reacting, but it's very, very slow. So zinc reacts slowly with acid, particularly in this form, in the granules form. Sometimes when we break it down into the powder, it reacts a little bit more quickly because your powder has a bigger surface area, it reacts more quickly. But at the minute we can see this is reacting, but very, very slowly. So you can already start to have a think about which of these metals do you think is more reactive based on our reactions with acid. I'll give you a zoom into this in just a second. But with copper, we saw absolutely no reaction whatsoever. So no reaction with copper. With magnesium, we saw that it did react. Our observations, which you can note down in your booklet, were that we saw fizzing, so bubbles of colourless gas. We saw that heat was released. We saw that the metal, the magnesium, eventually disappears and we're left with a colourless solution. And then with zinc, we can see that it's reacting very slowly. In fact, you might not be able to see it reacting from where you're at, but we'll zoom into it in just a second. And again, it's producing a colourless solution. Not so much heat being given out with this one. It will be as it reacts, releasing a bit of heat, but because it's reacting with so slowly, we don't feel that so much. Eventually, if we left this long enough, the zinc would all disappear. We might need to add a wee bit more acid to get it to do so. But it reacts very, very slowly. So that's a reaction of copper, magnesium and zinc with acid, and let's take a closer look so you can see that a bit more clearly. So what I've got here is my copper, my magnesium and my zinc. I haven't added any acid to the magnesium yet, so that's why you see it not reacting. So on the left we've got our copper. You can see that there's no reaction whatsoever with the copper. In the middle we've got our magnesium, but as I said, I haven't added the acid yet. And on the right hand side we have our zinc. If I just move that around a little bit, you can see the bubbles of colourless gas just on the surface of the zinc granules. And if I tap it gently, you should see those rise up to the top. So to give it a little bit of a shake. So you can see copper's not reacting at all. Zinc is reacting, but very slowly. Keep an eye on it. You should see a few of those little bubbles rise up to the top. You can see very, very small ones doing that right now if you look very closely. And then I'm going to get my magnesium reacting with the acid now. So I'm just going to pour acid over it. Okay, so I'll add a little bit more. You can see magnesium has quite a low density, so it is floating up to the top of the acid, and you can see it reacting away. And so it's producing bubbles of colourless gas, it's fizzing away. So you can see that's happening much quicker than the zinc that's beside it. If I take that out, you can maybe see that a bit more clearly. So you can see it's producing lots of gas, it's fizzing quite vigorously. Much more vigorously compared to our zinc, and especially compared to our copper, which is not reacting at all. I give it a bit of a swirl, just to get all that magnesium reacting. So remember, this is magnesium reacting with hydrochloric acid. So the salt we are producing is magnesium chloride. And the gas that is being produced, those bubbles of colourless gas, or hydrogen gas. So in just a minute we'll test that gas to see, is it definitely hydrogen? You can see the bit of magnesium is getting smaller and smaller. That last bit is just up at the top. So the magnesium is disappearing. And again, if I was to touch the outside of this, you can feel that it's very, very warm. So eventually the magnesium will disappear. And what are we left with? We're left with a colourless solution. So your observations are fizzing, or bubbles of colourless gas produced. Heat is released. The magnesium metal disappears. And we produce a colourless solution. So what we're going to do now is we're going to repeat the experiment of the reaction of magnesium with hydrochloric acid, but this time we are going to collect the gas and we're going to test it to prove its identity as hydrogen gas. So what I've got set up here is a gas kit, a kit for preparing gases and collecting them. So what we have here is just a holder and a boiling tube with a side arm on it, a little bit of rubber tubing that's connecting it to a delivery tube. So what that will do is deliver the gas that's being produced in our reaction. Our reaction is going to take place in this boiling tube. Hopefully you can see from the video I've already got my piece of magnesium in that boiling tube. And on top of this boiling tube, it is stoppered with a rubber bung to prevent too much gas from escaping. And then we've got what we call a thistle funnel, which will allow us to slowly add our hydrochloric acid in to then react with our piece of magnesium. So as I said, the gas that's produced will travel along this delivery tube. And in here, we've got a container that is full of water. So we collect hydrogen, as we say, over water. So what we've got here is what we call a beehive shelf. You can see there's a little gap here, and that's just allowing my delivery tube to go in under here. I'm going to place that on top there, and what happens is, as you can see here, it has a hole at the top and the gas is going to go up there, and on top of that I'm going to put a boiling tube that is filled with water. Okay, so here you can see that my boiling tube, I've just taken that up out of my water, that is filled with water at the minute, and I'm going to place it on top. Now when I do my reaction, I'm going to not put that over just at the very start. What I'm going to allow to happen is a little bit, the first few bubbles to come off, because at the minute there will be air in this boiling tube and there'll be air in the delivery tube, so I'll allow the first bubbles of air to come through and then collect my hydrogen, just to get as much hydrogen in that boiling tube as possible. Okay, so I'm just going to dry my hands slightly here before I do this. Okay, and let's get the reaction going. So when I pour this acid in, watch for the reaction here. You should see observations similar to what we saw a minute ago, where the magnesium starts to fizz and bubbles of gas produced, and the magnesium will start to disappear, leaving a colourless solution. So let's pour a little bit in here. Okay, and you can see already that's starting to react. And what I want to do now, by now all of that gas being produced should be hydrogen. So if you can see, I'm just setting that on top. Again, I'll dry my hands just quickly. Hopefully you can see the water level is dropping now, and that's because the gas that we're producing in this reaction is displacing the water. It's taking the place of the water, and then if we could see closely enough, the water level in our container would be rising slightly as that water is displaced. So you can see this boiling tube is filling up with hydrogen. Once I think it's full of hydrogen, I'm going to take it off and stopper it using a rubber bung so that we can then test the hydrogen. So it's nearly filled with our hydrogen. I'm just going to lift that off a wee bit, get a little bit more. Okay, and as quickly as I can, I'm going to stopper that so that I can collect as much of the hydrogen as possible. Going to collect one more test tube or boiling tube of hydrogen. Again, I've just got another boiling tube that is filled with water. Now I might need to add a little another strip of magnesium, because that reaction is now finished. So I'll grab another bit of magnesium. Okay, and I'll put that in here. So I'll just lift this off gently so that it's not to knock that over. There'll still be a little bit left because I can still hear a bit of fizzing. But if we add our other strip of magnesium, you'll see this will get going much quicker again. Okay, so you can see much more hydrogen gas being produced now. I'll just stopper that and put it out of the way. So, what we know is that we're producing hydrogen gas, but we want to prove that using our chemical test. And we saw that chemical test last week. Hopefully you can remember what it was. So the test for hydrogen is that squeaky pop test. But what does that actually mean? What do we do in that test? Well, what we do is that we light a splint. So I've got some splints here and some matches. I'm going to light a splint and then I will place it in my boiling tube of hydrogen. And if it really is hydrogen, then it will burn with a squeaky pop. Okay, so we'll see that explosion, we'll see a flame. Remember, we saw that in slow motion last week, and we'll hear a squeaky pop as it burns, and that's just the hydrogen exploding. Hydrogen explodes or burns with a squeaky pop. So we'll let a little bit more collect in there, and then again I'll stopper that so that these boiling tubes contain just hydrogen. Now, as I said last week, sometimes this doesn't work as well if the boiling tubes are not completely dry and clean, and obviously they were filled with water, so we might not get just as powerful a squeaky pop as last week, but hopefully it'll still be good. So I think that's filled with our hydrogen now. Let's get as much as possible and stopper that, okay? Because we want to collect as much hydrogen as possible. Why do we need to do these tests? Well, we know so many gases that are colourless. We know that carbon dioxide is colourless, oxygen is colourless, nitrogen is colourless. So we want to test to see, is this really hydrogen? So I'm going to move this slightly out of the way and then show you this. So these test tubes should be full of hydrogen. Okay, so what I'm going to do, and this is hard to do with just one person, it's easier if you have two pairs of hands at this stage. What I'm going to do is I'm going to light my splint. Okay, and then I'm going to take the stopper off of this and put my lit splint into it as quickly as I can to try and get that hydrogen to burn. Okay. Okay, and hopefully you saw your squeaky pop. We'll try that one more time with our other one, our other boiling tube of hydrogen. Okay, and we got a good squeaky pop with that one especially. Okay, so that proves that the gas that we've produced with a metal reacting with acid is hydrogen. Okay, so when a metal reacts with an acid, we produce a salt and we produce hydrogen. In this case, we had magnesium reacting with hydrochloric acid, so the salt is called magnesium chloride. The gas is called hydrogen, and we can prove that by burning the gas, collecting it and burning it. And the fact that it burns with a squeaky pop proves that it is hydrogen. So from the video of the reactions taking place, you should have noted down your observations of the reaction of copper, magnesium and zinc reacting with hydrochloric acid. And at the very end of the lesson, you can check the teacher copy to check you've got those correct. What we want to have a quick look at now is how we write word equations for these reactions of metals reacting with acid. So we mentioned this a couple of times in the video. It says the acid used was hydrochloric acid, and then it asks what type of salt is produced when acids react. And then it says think back to your acids and bases unit, but you may not have fully finished that last year because of the lockdown. What I also want you to add in your notes on page 8 is the question should really read what type of salt is produced when hydrochloric acid reacts. And it's asking about when it reacts with metals. So just put that in because the name that we're going to give here is particular to hydrochloric acid. So when a metal reacts with an acid, we produce a salt. The first name of the salt always comes from the metal. So the first name of the salt, type of salt, is going to be metal. And you can see that's a generic name because we don't have the name of a specific metal in here at the minute. And the second part of the name comes from the acid, but the acid name changes slightly, and we'll have a look at that in a second. So the type of salt we produce with hydrochloric acid reacting with metals is actually metal chlorides. So hydrochloric acid changes its ending to chloride. So the salt that we produce is a metal chloride. The next part of your notes asks you what is the general word equation for the reaction of a metal with an acid, and the hint is MASH. And this was covered in the video, so see if you can think about what this is yourself. Even pause the video if you can't think about it right away. But when a metal reacts with an acid, what is the general word equation? In other words, what are your general products that start with S and H? So hopefully you were able to think of the final answer. The general word equation for the reaction of a metal with an acid should be metal plus acid. Those are what we call our reactants, the things that react together, and that's the M and the A. And they react together to give salt plus hydrogen. That's the S and the H. So salt is just the general name. And we will spend a wee bit of time naming those in just a second. And then the H is for hydrogen. So any word equation you write with any metal reacting with any acid should follow that general equation. So using that information, the information that we have written down, I want you to try the next bit yourself. So it says, using your answers to the questions above, give the word equations for the reactions of the metals that reacted with the dilute hydrochloric acid above. It then says you should only have two equations. Why is that? Well, it's because only two of our metals reacted, and have a think back to which of them that did react. It says leave room for the balance symbol equations underneath. So if you write your first one about here and your second one about here, leaving room for your balance symbol equation, which I'll take you through afterwards. So I want you to have another read through the information on page 8 and to give that a go. Think about the two metals that reacted and how you could write a word equation for their reaction with hydrochloric acid. So this time it shouldn't be metal plus acid gives salt plus hydrogen. You should actually name the metal, name the acid, and name the salt. So see if you can work that out from the information that you've been given on this page. So pause the video now, and then I'll take you through to see if your answers are correct. So the first metal that reacted was magnesium, and it reacted with hydrochloric acid. So if you remember back to the start here where I said what type of salt is produced, well, with this case, we're going to get metal chlorides. That's because the first name of any salt will come from the metal. In this case, that is magnesium, and it doesn't change its name. So the first name of the salt is magnesium. The salt has two names, and the second name comes from the acid. But remember, we said the acid doesn't stay the same name, it changes its name. And hydrochloric acid changes to chloride. So the name of the salt is magnesium chloride. And you can see I've colour coded it there so that you can see where those two names come from. If we used a different acid, the second name would be different. So for example, if we reacted magnesium with sulfuric acid, the name of the salt would be magnesium sulfate. So the salt gives us the name of the metal that we reacted and the name of the acid that we reacted. But what you can't forget at the end is the fact that we produce hydrogen. So the end of your equation should be plus hydrogen. So the full equation should be magnesium plus hydrochloric acid gives you magnesium chloride plus hydrogen. Now you don't need to write the acid and the chloride on this separate line. It's just so that I can fit it all in from left to right. So if you've written it in all left to right on one line, that's perfect. Then we had zinc reacting with hydrochloric acid. What's the name of the salt going to be this time? First name from the metal, so that is zinc. Second name from the acid, but the acid changes its name from hydrochloric to chloride. So the salt this time is called zinc chloride. And then we need to remember that we've produced hydrogen as well. So our overall equation is zinc plus hydrochloric acid gives you zinc chloride plus hydrogen. What we want to do now is write our balance symbol equations underneath these word equations. And just a reminder that you don't need to know how to write balance symbol equations at this point. But again, you can look for patterns within them, but I'm going to take you through it now. Really what we do with balance symbol equation is we convert the words into the formula, so the names of the reactants and products into the formula. And the balance part is just about making sure we have the same number of atoms on either side of the equation. So magnesium, the symbol for that is Mg. Just write this along with me and don't worry if you don't fully understand this at this stage. Hydrochloric acid, the formula for that is HCl. So that shows us that we have one hydrogen and one chlorine in that molecule. The formula for our salt, magnesium chloride, is MgCl with a little tiny 2 down at the bottom, a little subscript 2. That tells us that we have one magnesium and 2 chlorine atoms within that formula. And then finally, hydrogen has the formula H2, which tells me that in every molecule of hydrogen, there are 2 hydrogen atoms joined together, a bit like oxygen was O2. But what we can see is that this equation isn't balanced. If you look even at the chlorine, I've gone over it in green there. You can see that there's only 1 on the left, but there's 2 on the right, and we can't have that. So what we do is we balance it by putting a big 2 in front of our HCl. And what actually that does is it gives us the right number of hydrogens too, because you can see there are 2 on the right, but originally there was only 1 on the left. So that big 2 gives us 2 hydrogens as well. Again, did that really quickly, but don't worry if you don't understand that. That's not too important at this stage. Let's give that a go for zinc reacting with hydrochloric acid as well. The formula for zinc is Zn. The formula for hydrochloric acid, just as we've seen, is HCl. The formula for zinc chloride, again, is very similar to magnesium chloride, is in that it's ZnCl2. Plus hydrogen, which is H2. So you can see these balance symbol equations are very, very similar. And what we need to do again is balance it. Again, on the right-hand side, you can see that we've got 2 chlorines and 2 hydrogens. But on the left, we only have 1 of each. So how we solve that problem is we put a 2 in front of our HCl. To finish off this video, I'm just going to explain what you need to do on page 9, and then I will let you complete that. So on page 9, you need to, first of all, from your observations from this week's lesson, the reactions with acid, place the metals investigated into an order of reactivity, starting with the most reactive first. So remember that we looked at the reaction of copper, magnesium and zinc with acid. So those are the 3 metals from today. So those are not in the correct order, but put those 3 metals in order of reactivity. And then the next part asks you from the observations made in all of the experiments. So that is from lesson 1, 2 and 3. Put the metals copper, calcium, magnesium, iron, sodium, potassium and zinc into an order of reactivity, starting with the most reactive first. So you might want to look at your order of reactivity that you came to a conclusion of last week, and then factor into your decision the observations from today's reactions as well. So again, listing those metals from most reactive to least reactive. And then the last part of your work for this week is to just spend a wee bit of time learning the word equations for each of the reactions studied over the last few weeks. The easiest way, I think, for you to do this is to learn the general equations, which I have written on the screen if you want to take those down at the bottom of page 9. So in the first week, we looked at the reaction of metals with oxygen, and we know that when a metal reacts with oxygen, if the reaction proceeds, then we produce the metal oxide. So say that was copper plus oxygen, then your product would be copper oxide. Then week 2, we looked at the reaction of metals with water, and the general equation for that is metal plus water gives metal hydroxide plus hydrogen. And again, if it was, for example, calcium, it would be calcium plus water gives calcium hydroxide plus hydrogen. And then this week we looked at the reaction of metals with acid, and we looked at the general equation being metal plus acid giving salt plus hydrogen. Probably the easiest way to help you remember that one is thinking of MASH, metal plus acid gives salt plus hydrogen. So spend a wee bit of time learning those equations and then complete the short Microsoft Forms quiz to test you on these 3 equations and our work from the last 3 weeks. It's just a very short quiz and it won't go towards any of your overall results, but it will just give us an idea of how you've been getting on with your learning at home. And do also remember to check the completed teacher copy of the notes to make sure that you filled in all your observations correctly from this week.